so we'll just go through that.
Okay.
So last time we talked about tiling, and you remember, Linus, we talked about the tile on your grandma's kitchen floor, how you put all those together.
Remember that? Oh, yeah.
Yeah. All right. Well, we talked about that so we could kind of get an idea of what area was. Now, area tells us about the number of squares that we can fit in a shape. So you know how your grandmother's kitchen is shaped, I don't know, like a square maybe, or a rectangle, and all the tiles are little squares within that rectangle. So that's kind of what we're looking at here. That tells us a little bit about shape. So I was going to have you here create a shape for me. You were going to be able to move these blocks yourself, but it's not working, or it's not cooperating, so I'll just show you what I was going to do. So I was going to have you just create a shape with an area of, say, 4. So we would just pull our blocks up here. And this would be a shape with our area of 4. Can you count the number of squares inside the big square?
How many little squares are inside there?
1, 2, 3, 4.
4, that's right. So the area of this square would be 4, and we found that out by counting the number of squares in little squares inside the big square. So let's do another one. How many little bitty squares are inside the big one there?
Okay, now count them again. Count them again.
1, 2, 3, 4, 5, 6.
All right. So what would the area be of that big square?
That's a 6 box.
That's 6. That's right.
That's 6 squares.
So you kind of see how we get the square, or find the area there by just counting the squares within the shape. So.
Yeah.
All right, we'll go to the next one. So I won't do that.
I won't do that.
So I was going to have you look at drawings of some other shapes, and they were going to pop up here for you and to look at and see which ones you thought we could look at and find the area of the shape just by looking at the different squares inside of it. But since it's not working right, we'll move on to the next one. So today we're going to kind of talk about how we find the area of a figure that is composed of other shapes, kind of like we just looked at, except this time we're going to look at some triangles to see if we can figure that out. So hopefully when we're done, we'll know how to find the area of a figure by decomposing it and rearranging it. Decomposing, that just means taking it apart. So if we've got a big square with a bunch of little squares in it, then we just take that big square apart. So all we're seeing is the separate little squares. And we'll rearrange those squares to get a new shape to find the area. So here are the shapes that we're going to be working with. We've got a yellow square. We've got kind of a medium-sized red triangle. Then we've got 4 small blue triangles, and then 2 big green triangles. So we're going to be putting some of those together to see if we can make a different shape to find the area. So if you notice, remember we had some blue triangles. We're going to take 2 of those and see if we can make a square out of it. So this square has an area of 1 square unit. So 1. The area is 1. So you see these blue triangles here?
You see those 2 blue triangles? Do you see those 2 blue triangles?
Yeah.
Yeah. Okay. You see down here how we put them together?
See how I did that?
See how they're put together here? We've got 2 triangles and we put them together. What does that look like?
What shape is that now?
Square,
yeah, that's
it's
right.
It's a square, that's right. So it looks exactly like this one, doesn't it?
Square.
Does it look exactly like the yellow one?
Yes.
It does. So do you think those areas would be the same? They look exactly the same, so the area will probably be the same too, right?
Yeah.
Yeah, that's right. So if the area of the yellow square is 1, that means the area of this blue square is also going to be 1 because they're exactly the same. On the next one, we're going to take those triangles I was showing you and see if we can make another shape with an area of 1.
Question. Trillion trapezoid.
That was a triangle.
Yeah, my computer is really slow. I think my computer thinks it's still Monday.
Correct.
I thought today was Thursday.
Agree.
I can't keep the day straight anymore myself. All right, so let's take these 2 triangles that we were working with earlier and the square. We'll move these out of the way. And let's zoom in a little bit. So we'll just move this one around.
Correct.
Yeah, let's move this one around. I can kind of show you what you saw earlier on that previous slide.
Yeah, true. Yeah.
See how he's moving them?
Really? Who?
Okay, we got 2 triangles right here, right?
Oh, correct.
So what happens when we put them together? Like we showed you. Looks just like that square, doesn't it? See that? Yeah, so those areas are equal. So let's see if we can make another shape out of this. We're using the same shapes we had before. We're just going to make a new shape.
You see that?
Yeah, sorry.
What kind of shape is that?
What shape is that?
Triangle.
Triangle, right.
Good job.
I'm charged.
So what I'm showing you is, one, when we can take a shape, and if it fits over top of the other one exactly and matches up, then they have the same area. So the area of this square is exactly the same as the area of these 2 triangles that are put together. And then also, we can take those 2 triangles and break them apart and make a new shape out of them.
Oh, yeah,
See how he's making a new shape?
yeah. Triangles.
We can make a new shape out of them, but the area is still exactly the same, even though it looks different. So if the square has an area of 1, then these 2 triangles put together have an area of 1. So what we did there, it's called a compose. When we make a shape, we put shapes together to make another shape. Sorry, I'm making myself dizzy here. We make a new shape. It's called composing. We're composing a new shape. If we take that shape and break it apart, we're decomposing it, or we're breaking it apart, okay? And then when we make a new shape, we're just rearranging those shapes to compose a new shape, okay? So let's go back to our slides here. So what I was going to have you do was to draw a shape on here that we made, but since it's not working right, we'll skip that one too. Since you were able to kind of see what we did right here, right?
Right.
All right. So let's go to the next one. So this slide was just going to show you after you drew your own shapes out of those triangles. These were some of the options that you could have come up with. So you can see we're still dealing with the same 2 small triangles, but we can make 3 different shapes out of them. 3 different new shapes out of them. We'll go to the next one. So just to summarize kind of what we just went through, we can use these 2 principles or these 2 ideas to help us think about area. If two figures can be placed one on top of the other so that they match up exactly, then they have the same area. So what that means, like we saw when we used the square, we can take two triangles and put them together. And if you move those triangles on top of that square and they're exactly the same, then they have the same area. And then the second one there says if a figure is decomposed and rearranged to compose another figure, then its area is the same as the area of the original figure. So what that means is the original figure we had was a square. So we took those two triangles, composed them, put it on top of the square, and it looked exactly the same. So that area was the same. So then we broke those triangles apart and then rearranged them to make a new figure like we saw on the big triangle. But since we used those same shapes to make that new shape, then the area was exactly the same.
Opposite theory.
And this just kind of talks about, it's a picture of what we just talked about, composing, decomposing, and rearranging. So here we've got four triangles that come together to make or compose a big triangle. So if we don't know the area of this big triangle, but we do know the area of these little ones, we can put those together and combined, those will tell us what the area of the big triangle is. Then right here, we've got the big triangle, again composed of those, or made up of those small triangles. We can break those apart to find the area of those smaller triangles, say if we know the area of the big one. And down here, we just compose it, but we rearrange them to give us the area of those squares. So what I'm going to do, I'm going to post this. This was something you could have done in the presentation, but again, I'm sorry it didn't work. It wasn't working properly.
You tried.
That's the story of my life right now. But I will post this on Google Classroom, and this is just a little quiz to see if I made any sense today. And if not,
Okay.
we'll try to go back through it. So I will post this here in a second, and just work on that. And I guess through the weekend, I'll make it due Sunday, so we've got a few days to do that. But
Okay.
that's where we are.